Hey everyone, today on this video we're going to show you a super unique project that we have presented to us by a customer where he has slammed, cambered out, lowered and engine swapped a Porsche, what's it called? You have to like get a voice to say like
Porsche Cayenne LS2 swap.
He presented us with this issues and he brought me all the original components and he said, can you make something that will work for my setup? His biggest issues were when you lower a car a bunch, you have a major roll center correction problem. Basically, his upper control arm is pushed up so high that it's now hitting the chassis, and the lower control arm is at such an angle that the ball joint is maxed and all of your geometry is completely off. So basically what we need to do is a drop knuckle where this bearing is mounted higher in relation to the pickup points, but we want to leave like your bump steer features and everything else basically OEM. So with this, he also said I want it to be longer and adjustable while on the vehicle. So that's a second challenge that we need to come up with, where we need to be able to lengthen or shorten the arms and adjust the caster while on the vehicle using all of these crazy components that luckily I've developed over the years and we have in stock outside. So what I'm gonna do is go out, gather all of these odds and ends, put them on the table and say, this is gonna go here, that's gonna go there. I've already designed the arms and cut the arms on our water jet machine out of this high strength alloy steel that's super cool because it's so strong you can put big cutouts in it and it still will outperform all of these factory aluminum pieces, which is going to be perfect because the Porsche is kind of a heavy vehicle. So let's go ahead, gather up the other pieces, and we'll do direct comparisons between what I came up with and what the OEM component looks like and how I solved the problem of making our new arms. Come with me. So here we have a entourage of spacers, bolts, more spacers, and all of the bits that we're gonna need to make this work. Here, we're gonna be matching the size of the bushings so that we can bolt our bearings to the car. All of our bearings are the same diameter and width. So these are a COM12 bearing. They are 3/4 of an inch or 19 millimeters wide. We need to adapt this to a vehicle which obviously has a subframe spacing of X. We don't know what it is. We need to measure it. But basically, I'm going to use one of these sets of spacers to bridge that gap and make this installable where you can tighten it down and this is going to be fixed to the car and constrain it basically. So from there, we're going to go and we're going to find our, over here, where we have our Heim joints. I'm going to grab a bunch of these. Our water jet guy has been kind enough to put jam nuts on all of them already. These are a high strength chromoly 3-piece Kevlar lined Heim joint. These are about the best you can buy. That's what we use. We've been using them for the last couple years and they have been fantastic. So we're gonna take the ones of these that fit and apply them to our adjustable version. But you can't adjust this while it's on the car because you would have to unbolt it, thread it in, and then rebolt it. He doesn't want this. He wants to be able to do it without taking it off. So with that being said, we are going to take one of these. We are going to pair it with one of these. So what this is a left-hand internal thread and a right-hand external thread, where when I thread this on, the Heim joint's left hand, the outside is a right hand. I have a hex machined in the end so I can stick an Allen key in, turn it, and this will lengthen and shorten the length of the arm without taking this off. So I need to find a female bung that I can thread over this and then weld that to the arm. So follow me. This is gonna be good, isn't it? So over here we have the weldable components that allow us to fixture these items to control arms. This is just one little thing. We have a couple other shelves of parts, but from here, this is where we're gonna find this part. So fresh from the machine shop, we have chromoly locking bungs, and this threads onto there like so. We are able to weld this to the control arm. We are able to lock it without a jam nut by tightening this split with 3 bolts. And from here, when this is welded to the control arm, if I spin this in any direction, it's going to change the length without having to remove the control arm. So it's a beautiful thing. I can put these on the upper control arm so that he can adjust his camber without unbolting anything. Now we need to solve the problem of the lower control arm. I'm going to show you what I came up with after we carry all the arms to the table. So the arms are over here. This just looks like a bunch of junk right now. but I assure you it's not. So let's take this over. With all of this nicely cut alloy steel made on our water jet, designed by yours truly, we're going to put together what I told you we are coming up with. Yep, here we go. So you're gonna get a general consensus of what we're doing with these arms. So right off the bat, I'm gonna grab a couple more components. You kind of got an idea of what I'm doing by showing you like where I grabbed all of these parts. So I'm gonna do the same with everything else and I'll be right back. And here we have the components that we're gonna need, obviously more than just one, but I'm just gonna show you one because that's all you need to get the right idea. This is a uniball cup made from chromoly. This is going to be what goes here and gives us our ball joint for the outer ball joint on the upper control arm. These are gonna be on both sides of the inner, so that we'll easily be able to access this with an Allen key and be able to lengthen and shorten the upper control arm, like I said. On its shortest setting, we are already gonna be at the factory length. That is because he is going to be widening the track width of this particular setup. So we know that he wants to be at a minimum the factory length and at a maximum beyond that. So that's why we did that for this. That is the upper. It is probably the easiest of the three. The lower, you can see the tie rod passes over this portion of the control arm. It has this offset design where the arm droops down and then goes up into the bushing and connects to the subframe cradle here, and then the knuckle there, and the shock bolts here. So we had to make a lower control arm out of this alloy steel that's gonna resemble the shape and give us the same swoop. We're gonna use the same piece that we're going to be welding onto the upper, and we're gonna weld it onto the lower. On the lower, we're gonna be doing a double shear design on the knuckle, so we're gonna get rid of this tapered ball joint style, so that part of that is easy. We have a locking bung that is gonna be welded in this location. We're gonna be pointing this down so that we can easily tighten it on the car. So that is going to be welded there. And on this part, this is where we're gonna get our caster adjustment for the lower control arm. So we have this chromoly piece that goes into this pocket on the control arm. The heim joint is gonna be threaded into the back. So this is going to be our connection point where we're gonna be putting two misalignment spacers on either side to match the width of this bushing. This is gonna be installed onto the car. And as I turn this side of this adjuster, it is going to pull in the arm or extend the arm like so, and I will simply lock the nut in place once I reach my desired caster point. Because the control arm is a one-piece lower control arm, it is going to be pivoting off of this point, giving us a rotating feel, which will swing the outer ball joint, pitching the bottom of the knuckle forward or backwards, which is going to be giving us our caster setting. The caster can also be adjusted using the upper control arm. You can lengthen this side and shorten this side or vice versa, and that will pivot the top of the knuckle. So we're able to adjust the bottom and the top of the knuckle to get our desired caster setting. And because of this, as you pivot the lower control arm, the distance between these 2 points is also going to change slightly because we're rotating it on an arc. So that is why this has a slight slot designed in, so that if you pivot it all the way in one direction, it's going to be maxed out this way. If you lengthen this in the other direction, it's going to be maxed that way. Giving us a bit of play here is important, but under load, this is not going to result in any sort of deflection because we are not applying a load linear, it is a rotational force. So I hope that came across as simple as it is in my mind, but if it doesn't, it works. So the next thing, which is the most complex part of the kit, is going to be the steering knuckle. This is where all of the geometry comes together and works as a paired piece with everything else. So because of what we needed to achieve, we had to make a drop or a roll center corrected knuckle. You can clearly see that our new pickup point is going to be centered between these two slots. These two slots are alignment tabs for our lower control arm mount, which is gonna go like this and like this. So our bearing is actually gonna sit in here, and it's gonna pivot and rotate on the lower control arm between these 2 points. And the upright of the knuckle is going to be installed like so in the alignment tabs, where this is going to be welded to that. This is giving us clearance for a bolt to pass through. And the next thing to show you is where and how does this compare with the OEM knuckle. So if we line up the bearing centers with each other, you're going to see the most important features of the knuckle, which are the roll center characteristics. He had an issue with his upper control arm maxing out into the chassis. You can clearly see that if the wheels are in the same position, we are no longer going to have that problem. We have created a huge amount of correction here so that he is able to lower the car without lowering the suspension, keeping everything in check. So the upper control arm is now going to bolt here, and it's going to be nice and parallel, whereas before it was on a massive angle trying to reach this point. This is where the lower control arm connected to, and this is the new lower control arm pickup point. The control arm went on top of this, so the pivot was here. Now the control arm goes centered here. You can see our difference in roll center correction there, which is going to really help with his setup. And then the last but not least is the tie rod pickup points, which are going to be done with these 2 plates. This is going to be a double shear design with some Ackerman adjustment. This is pretty important with drifting, not so important with just a regular car that has roll center correction knuckles. But basically I'm giving it to him because I already have these designed. It's going to use the same Ackerman plates that we use on all of our kits, and hey, let's say if he wanted to change or play around with the Ackerman, he's able to do that. It takes no extra time for me to do. So these are going to be installed. They have 2 alignment points here, giving it the correct spacing. That's going to go there. That's going to go there. And we are going to weld these to the knuckle, to this upright, tying in all of this lower section together nicely and giving us a replacement knuckle with the brake mount ears incorporated on it, whereas in this knuckle they kind of bolt here and then they have like an adapter to hold the mounts. It's kind of a weird design. Maybe they did it because it's aluminum. I know the later generations for the Porsche, they later went to actually no, I think it was steel first and then they went to aluminum, probably to save some weight. So this is a later generation. I don't know these cars as well as a lot of other chassis, but it's kind of irrelevant for the problems that we're trying to solve. So the brake mounts are on here. Everything already fits. I've test fitted the bearing. I've gone over this on my computer and simulated the changes that I did. This is going to work really well. So now the only thing left to do is to weld it all together, get it powder coated the custom color that he wants, and deliver it to the customer, or he's probably gonna be picking it up, to be honest with you. And yeah, it's gonna be really cool. So this is just a little look at what we do, or what I do on a daily basis. This is a good inside look at the capabilities of our company as we continue to grow. What we're able to do in-house is pretty much limitless. So with that, let's get some good shots of welding and fabricating this kit together. Obviously, I have 2 of everything to make a left and a right for him. And then we are going to finish it off and install it. So I've almost finished welding everything. I just need to add 2 bungs in the top, which are gonna act as a thread for us to put a bolt through and into the top of the knuckle. Otherwise, everything is ready to go to powder, and I also need to make the bearing mount for here. Really easy stuff. We're gonna finish that stuff up on Monday. The majority of the work has been completed. So if you come in here and you look at everything, we've got our double adjustable bungs welded in place. We've got our uniball cup welded in place so we can press our uniball bearing and install a snap ring. That's going to secure the bearing on the outer ball joint. The inner ball joints are going to be those double adjustable heim joints just like this, where you're going to be able to stick an Allen key in the end and lengthen and shorten the arm. On this one, we're going to have the heim joint in the end with the locking bung. I had to run it sideways instead of down like I said earlier. Just it's better access to put it there. So the outer is the uniball. See, it's nice and secure on there. This one has been welded all the way around for, again, a secure attachment. So now this is all one piece. This is going to be our pivot point. This is going to be our caster adjustment, where the arm is going to simulate this on the car, which is where this piece comes in handy, and that is how we're going to be doing that. Everything is going to be easily accessed. You compare it to the OEM components like we did earlier, but now everything is welded. You can see how the Ackerman adjustable double shear points on the knuckle are connected now. With the welds, we had a little bit of a clearance here for the bolt. Everything is just gonna fasten as if it was factory. As you can see here, we have 4 holes. We have 4 holes, the brake mounts and everything. That's it. What we're gonna do next is clean everything up. There's a couple sharp edges here that we need to take down and so on. Don't mind the rust. I know you guys are probably like, oh, why is it so rusty? When things come out of the water jet, it's a very bare metal surface when the sand and the water blasts through it, and it basically is in water. So it's a flash rust. It's very easy to remove with a sandblast, and once you powder coat it, it's completely fine. It's gonna look beautiful when it's done, all in the custom color that the customer wants. So we're gonna keep you guys updated with the final bit of the kit. That is a really quick overview of like a really quick start to finish on a development, design, and manufacture of a product. Obviously this one is different than changing the geometry. We actually basically kept everything the same, but we made it adjustable, and we corrected the roll center on the knuckle, and that was pretty much it to do with that. I know he had a slight wheel clearance concern, so we made a little more clearance here for the knuckle. That was literally it. The kingpin axis, the camber, the settings that he's going to be able to run and everything is pretty much the same as the OEM factory components. That's it. That's it for this video. Thank you guys for watching. Hope you guys got a little more insight on the things that we do here at FDF, and we'll see you guys in the next video.